Hello people, welcome back to my channel. So today in this video we'll be discussing about a new topic in machine learning, that is semi-supervised learning. So the main paradigm in machine learning is that we use different kinds of learning techniques. Like we have seen supervised learning where we use the labeled data, and there are cases like unsupervised learning where we completely rely on the unlabeled instances, but that is not a learning process, but it's a clustering process. So there we don't build any models as such, but in supervised techniques we build certain models like naive Bayes or decision trees or linear SVMs and so on. So the thing is to get the labeled instances from the real world or in any domain, whether it's healthcare industry or medical industry or finance industry, anywhere where you apply data science or machine learning, getting labeled instances would be pretty difficult and it would be a very Herculean task. But the process of getting the unlabeled instances would be very easy. So say for example, if you have a very large dumping ground and people dump their waste in form of bean bags or something there, and if you are asked to classify what these things are, so it becomes easy, right? So these are dumps, and if I ask like segregate biomedical waste or any hazardous waste out of this, so it's even more difficult. You have to then tear the bags and look for what the things inside are, whether they are radioactive or they are biomedical. So it becomes a very challenging task. So why we require SSL techniques is that we can make use of both these things, that is both the learning techniques, that is the supervised, as well as both the unsupervised learning techniques. So that's where our today's topic is focused into. So let's get started. So before starting this topic, let me first divide this into three parts. So first we will have some of the goals, why we require to do the semi-supervised learning, or why in the context, especially in machine learning or data science, we talk about this particular semi-supervised. Although it's not very commonly used and some of the algorithms are not known, I'll be introducing them later when we go into the more depth of this topic. Then what all are the challenges or the problems that are encountered? So that is one thing, whether it's supervised or unsupervised, any kind of learning algorithms, you will have some of the problems and some of the use cases where you can apply this, or where in the real world you get to see this semi-supervised learning strategies. So let's begin. So what are the goals? So as I mentioned, getting the labeled data is very difficult, but the unlabeled data, it's available everywhere freely. So why not to make the best of both? So use the labeled data plus unlabeled data for building your model, whether it's for classification, prediction, whatever your problem domain is. But how much to choose, or what should be the portion of this labeled and unlabeled data? There should be some estimate. So usually it is a 20 to 80 ratio that is followed. You take a 20% of the labeled instances and rest 80%, that is majority of the unlabeled instances, goes, or that is a problem setting. So the thing is, you have to try with different kinds of settings. Like can be also possible, like you can take 35-65 or 30-60 or 30-70, anything. So then later when you get into the more depths of this, you can then split this into training, testing, validation set, or things like that. So that gets it more complicated. So let's keep it simple. So we partition the, or we have the initial setting as the labeled as well as unlabeled set. where the labeled set is very small because it's very difficult to get, and you require certain human annotators or some kind of other techniques or Amazon Mechanical Turk, something like that, external outsourcing tools in order to label these stuffs. So that's where the labeled instances comes into picture, and the unlabeled instances we can get it freely. So according to a requirement we can scale it up or scale it down. So essentially this is the rationale behind why we need to have the both labeled and unlabeled instances for our use case. So with this thing or with this setting, what we build is we build a prediction machine or a predictor something or a classifier. So we can have both of this depending upon our use case, and then we can solve our machine learning task. So that is the basic idea of this ground level knowledge of what the semi-supervised learning technique is, or what it basically comprised of. So there are pretty few algorithms in the literature which are not widely known, because people don't talk about these techniques, whether it's for text mining or text classification, or whether it be image classification, or in any of the scenarios people don't talk about these things. But generally when we talk about semi-supervised learning, it can be done in two of the ways. So first way is called as an inductive approach, and the second one is called as a transductive approach. So we will cover these two techniques, or what these things are, in a detailed separate video, what these things actually means. So there are two categories or two ways by which you can do the SSL technique in machine learning. There are few algorithms that I will list here. So one is called as a S3VM. So that is a variant of your support vector machine, which is meant to behave in a semi-supervised way. So the S3 stands for semi-supervised support vector machine, or S3 SVM, or sometimes it is also called as the TSVM. So TSVM comes from the transductive side, so it refers to here. So that is the usual SVM, how it works. Just for the semi-supervised setting we have the S3VM. Then we have certain graph based techniques. So graph based techniques are basically from the inductive side. So usually people go with the graph based techniques because the implementation is quite easy. You don't have to build any custom libraries or user defined libraries for that. Just from the basic implementation you can override, and you can write your code, and you can make it function according to your domain or whatever you are trying to solve. In graph based you have two techniques, like you have the label propagation algorithm, LPA, and you have the label spreading algorithm, by which you can do this kind of stuff. There are other techniques by which you can make use of the SSL implementation, and that is by means of mixture models. So mixture models usually comes under the generative techniques. So some of the mixture models, or the most popularly used, is called as the GMM or the SSGMM, semi-supervised Gaussian mixture models. So these are also behave to work in a semi-supervised way for this particular setting. So I just gave a brief idea of what the goals are, or the learning goals, and some of the algorithms that we can make use of this. Or you can also go with some ensemble techniques, where you can combine multiple other predictors, and then you can use their computation power in order to solve your classification or prediction problem. Let's move on to the problems that is mainly faced with these things. So the primary kind of problem, or the root form or the root cause where SSL are not getting better accuracies than any other deep learning techniques or so, but currently the research is going on in this field, is because it mainly or heavily relies on certain assumptions. So what these assumptions are? So assumptions, when I talk about this thing, it leads us to right here at this point of time. So when we talk about this labeled and unlabeled instances, at the very beginning you have a 2080 partition. So who said that I have to take 2080 partition? I can also go for 10 and 90 partitions as well. I can go for 45 55 partition as well. I can go for 40 60 partition as well. So what happens by this kind of assumptions? So whenever you make this kind of split or this kind of partition, your output will behave accordingly. Depending on the partition, it will feel that the labeled instances are not so much, or it is very less, or the unlabeled instances are very higher, or you have to compromise on some portions. So you have to make multiple trials and then execute them. Only then you will get a better accuracy or a comparable standard as to other benchmark techniques. So that's where one problem with this SSL technique is. So the assumptions, not only here, but when we go with this individual algorithms, depending upon our use cases, how you want to classify these things, you have certain problems here also. So sometimes depending on your problem, you have to make custom modifications in the user library, or you have to override those things from this base implementations for these techniques, because these are author specific algorithms. But if you want to implement, say suppose tomorrow if I want to implement random forest which will behave in a semi supervised way, so you have to do some research, and then you have to take the ensembles or some of the best from both or all of these algorithms, and then you can make that algorithm work. So there also it's not guaranteed that you'll get a better predictive power, because again it's a rationale that you try to split your labeled, or you make use of this kind of partitions. And along with all these algorithms, whatever I have discussed here, they themselves have their own assumptions as well. So you have to very much keep up with these assumptions, else if you are not able to do so, or if you fail to do so, and if any of these assumptions from this algorithms fails, then there is no point in doing the SSL techniques or SSL learning. So the learning goal or the outcome in the worst case would be very less, so that it cannot be even compared to other benchmark deep learning techniques or any supervised learning techniques. So this is couple of problems. And so talking about the labeled instances, I have already mentioned, like you have to hire some annotators or some of the other crowdsourcing tools, something like that, or there is an Amazon Mechanical Turk, AMT. So this particular thing will do the annotation for your instances, whatever it would be. So usually you might have seen when you fill some of the online forms or fill some of the details online, you'll get a grid kind of structure where you have certain images, and it would ask label all the taxis that are found or all the traffic lights that are found. So you can think that the data which they collect at that point would go for these things, because practically it's infeasible to make a human being sit there and tell him for 9 hours you have to label 9,000 images. It would be very difficult practically for any human being. So there they make use of this kind of crowdsourcing tools or annotation tools to label these instances, and also the proportion of unlabeled instances, that how much you want to take into account would be another issue. So these are the some of the problems. And talking about the use cases, say I said about assumptions. So assumptions should not be violated, but it should be very much followed through your entire data science journey or data science pipeline. So one common example that everyone can relate is the COVID-19 pandemic that is there. So if we are trying to build a classifier, something out of this, any of these algorithms, and by listing out certain assumptions, then what we have is, like, say we want to predict something, predict the number of cases or predict how many people has got vaccinated, how many is not more likely to get vaccinated, and so many kind of research questions we can propose, and we can make use of this SSL. So the thing here is, if you fail to pass any of the assumptions, or if you incorrectly state any assumptions in that problem formulation or while building your model, then that will be persistent throughout the entire journey till your prediction, but you will not feel that it would be the correct one or the incorrect one. So until it is visible that it leads to poor generalization, only at that point of time you will get to know that this model is not a perfect model, but some or the other where at places you are or you have to patch some of the points, or at some places you have to do something. So that's where this would be failure, but you can make use of that. But the thing is, like, these algorithms or whatever ensemble techniques you use, make sure what assumptions they are lying on, or what their assumptions they are following, and then you can make use of that. So assumptions is the key thing. So assumptions we have to always follow for SSL techniques. And one more thing is that the data distribution from where it is coming, whether it's a uniform distribution or normal distribution or Poisson distribution or Weibull distribution, any kind of distribution from the processes or the data generation from where the data is coming, both the labeled and unlabeled data, the data underlying data generation process should be exactly the same. This kind of assumptions are proposed by this SSL, but in the real life it's very difficult to keep up with these assumptions, because we all know, like, data doesn't comes from a uniform distribution always. Data doesn't comes from a normal distribution always. You have to do certain pre-processing, certain standardization techniques, certain normalization techniques. Only then you can bring the data to a particular point, so that after that you will get a good output for your process. So the data generation process should be the same. Especially this is a challenge when you have the semi-supervised GMM, but usually in the mixture models they already have the assumptions like the data is coming from the same distribution. So here the challenge is not much significant, but in other algorithms where you try to implement this would be a little bit challenging thing. So these are the use cases, and here we took the example of COVID-19 detection, infection detection using some of the SSL techniques. So I'll be touch basing on some of the algorithms later as we progress more into this section. So that's all regarding the semi-supervised learning techniques in machine learning. So hope you guys enjoyed this video. If you found this video helpful, please do like, share, comment, and if you are new to the channel, please consider subscribing. Thanks a lot for your attention.